Alrighty. Huh? Oh no, I forgot to plug that in. Sorry. I already messing things up this morning. Good morning, everyone.
Good morning. I'm Brian Walsh, and here with me today is Julio Valcarcel. Let's talk a little bit about Exerceo. So Exerceo exists to lead and inspire others to transform society by extending relevant learning and mentorship into everyday lifestyle. And so what does that mean for everybody here? Basically, what we're trying to do is help rising professionals successfully enter the workforce and successfully rise within the workforce. And so the working groups this morning is one of our tools. There's other great resources under learning on the Exerceo website. The Rising Professional Challenge Series, highly suggest that kind of the first year of your career. The Rising Leadership Challenge Series, I would follow that up shortly thereafter. Even if you don't plan on being in a leadership role, you'll find you're doing leadership activities. And so those will be helpful for you. So please check those resources out. And then one other note is we should have the attendance posted shortly. So don't forget to sign in, and we'll send you a copy of all the notes that we go over today for that. So we'll post the attendance link. All right.
That's the attendance is now posted.
Sweet. Okay. All right. So today we're going to go over cybersecurity for software developers and hosting and virtualization. So I'll let Julio lead off with the cybersecurity.
Yeah. So both of these modules are near and dear to my heart. They are sometimes the source of plenty of pain as well as opportunities for improvement. So this morning, the first half, we're going to talk about the cybersecurity for software developers, and then the second half, we'll talk about hosting services and virtualization. So talking a little bit about cybersecurity, I know we've mentioned it before in respect to system administration, and we've talked about how things like build automation, test automation all apply and help improve your security perspective. And hopefully the thing that's coming across in all of these is that security isn't just a one size fits all. It's not just one thing you can do.
One and done, baby.
It's never one and done. Case in point here, the first thing we want to talk a little bit about in getting you aware of as a software developer of kind of the common things you should be paying attention to are things such as SQL injection or cross-site scripting. So we're going to dive a little bit into what those are. These are primarily focused on SQL injection or just injection attacks or any application. Cross-site scripting is more of a web-based issue, but with the prevalence of web applications nowadays, it's a pretty common issue to run into. And then there are some other things in here, cross-site request forgery and cores. Brian will talk a little bit about dependency management and how that plays into it. And also PII and what you should keep in mind for that as a software developer. So diving a little bit into SQL injection. So, and I'm going to say more broadly, just injection attacks in general here. A SQL injection is a type of attack that happens when you're using a SQL database, aptly named a SQL injection, in that some part of your application is taking some type of input from a user, and a malicious user uses that input to pass through code or escape characters for SQL that allow them to do more than what they should be able to do. A good example of this is I think there's a meme out there, the Bobby drop tables, where someone names their kids semicolon drop table star or something like that, because the joke is that it's a SQL injection, and they test all the SQL or all the SQL escaping or stored procedures or prepared statements of the applications they put them into. So stepping a little bit more broadly, SQL injection is the more common one that people are aware of, just because it's a lot easier to go, and if it's a vulnerability, it's pretty easy to detect. There's in the notes here that we'll be sending out that we have some links to some demos that you can follow along with, including there's one for, let me see if this link is still good, hack explaining. They have a SQL injection how-to, and then Damn Vulnerable Web App is a web application that helps teach you the different types of injections, some of the injections that we're talking about today and some others that we're not talking about, how to go and execute those, and so that you can learn about how a malicious user would use those against your application, so you can start preventing against it. So more broadly, though, injection attacks are the same concept of being able to pass in something that your application isn't expecting and performing some unwanted behavior or unexpected behavior. It doesn't have to necessarily be unwanted. This is possible with NoSQL databases. It's possible with there's file injection attacks. There's a number of different things that a malicious user can do. So the key thing to do is a software developer when trying to prevent against injection attacks is to think through how data can get to your application. A common example of this that we see in more modern web applications that are using some sort of front-end JavaScript framework that runs in the client's browser and a RESTful API is that they'll do validation on the client side in the JavaScript code, not realizing though that the requests from the JavaScript are made from the client's browser, so on their computer, to your server. So the security boundary is really at your server and at your APIs. And so if you're only doing validation on the JavaScript side, it's very easy as a malicious user to go in and pass whatever really input that you want into the server without any additional validation there. So keeping that in mind, that's one of the more common ones we see nowadays with, again, modern web applications, but the concept still applies to if you're building a desktop application that connects to a RESTful API or to a database. You have to make sure that you're performing these validation steps and understanding where the security boundaries are within your application where you're doing validation. Typically what we'll do is we'll validate both on the client side, the JavaScript code, or the untrusted side, I'll say, of the application, to go and provide a good user experience. We'll go and say, hey, you need to have these fields set in order to save the field. And then on the API side, we'll also do validation. That way, if someone hit our API directly that we weren't expecting, that validation's still in place there as well, so they can't go and make a change that we're not expecting. So that's the concept of validation and ensuring that you don't have some form of injection attack within your application. Talking specifically about preventing SQL injections, there's a couple different ways to go and do it. Going through the ways that you shouldn't do it and that aren't really great ways to handle injection attacks in general is escaping the user input. This is going to be kind of the worst example. It's better than nothing, but it's definitely not the best. And if you're implementing this, you should not use barely good enough or not good enough. You should go to what we'll talk about here in a few moments. The idea of escaping all user input is saying, hey, well, I know that a single quote character is used to end a SQL string. So I'm just going to ignore a single quote character. And you're going to use some regex or some fancy find and replace to remove those from a query. Now, what happens if someone adds an and in there, or they do an escaped quote, or they pass in a URL encoded version of it, or some other thing that I'm not thinking about here? You have to start considering, when you're escaping user input, you have to consider every possible permutation that's available to you, which is possible. Technically, you could go read the specification for the whatever protocol you're reading, and you could go and write it all up. But that's a lot of time and effort, and it's still pretty error prone. People have solved this problem already, which is why we're we're saying not to use this approach. So I'm looking through here at our notes. We talk a little bit about ORMs. It's escaping user input. The other thing to note about it is writing it yourself, kind of like writing your own encryption. You just shouldn't do. You should use tools that exist already. It's also going to be database specific. So if you're using MySQL versus Postgres versus MS SQL Server, even though they're all SQL, they all use the same language, there are subtle differences between them that you would have to account for. So not every solution would fit. So the next best way to do this is with something called a stored procedure. A stored procedure, this is very much a SQL concept. I've started to see some cloud-based managed databases have this concept through a couple different ways. But the idea is what's called a stored procedure. And really what it is a fancy way of saying that it's storing your SQL query or storing code within the database or within the database's control to have it execute it for you. So what you end up doing is you essentially call a function on your database. You could have a stored procedure called get all users, and you don't pass it anything, and it just does a select star from your users table. And this works very well for preventing SQL injections, depending on how you write your SQL query. So it's not a silver bullet. There is no real silver bullet. And I'll say as a general rule, we say stored procedures serve they serve a purpose. They're good for doing things that are not easily done in your database or in your application code. But as a general rule, for my example I just gave there, like get all users, you don't really need that to be in a stored procedure. There are other ways of handling that type of query. Specifically, I'll say my familiarity is with the .NET ecosystem when it comes to SQL. There's something called Entity Framework that allows you to go and use objects within your C# code to go and query the database. And so it's a much more robust, you get in your editor or IDE, and at build time you get code completion and things like that, and you get the ability to check that the syntax is good. So stored procedures, they have a purpose, but they're not typically the best way to go about searching within or preventing a SQL injection within your application code. The way that we always recommend is either using an ORM, an object relation mapper, kind of like I alluded to, Entity Framework in .NET, Spring Data, JDBC, and Spring Data, I forget what their SQL project's called, but using that type of ORM to handle building your queries or in selecting data out, those typically will handle the security for you. The other way, if, for example, in like PHP, what we would do back in the day is we would use MySQLi and build out what are called prepared statements. And so what you end up doing is you write a string in your code that says select star from users where ID equals colon ID. And the colon ID at the end is essentially a string replace that the prepared statement library that you're using. In our case, we were using the library from PHP, would handle replacing and passing it in and escaping and doing all this logic for us. And so what we do is we say, just use this query as a template, but then just give it these parameters, these named parameters. We say, all right, the ID is going to equal this, and the user is going to equal this. And it will handle the building of that query for us in a way that is going to account for all of the different use cases that if you manually did it, you would more than likely not account for. So just sort of recapping there, prepared statements are our best option, or some sort of ORM that handles this for you, where you don't even write SQL queries. You just do, in C#, it's called link. It allows you to do, there's like a .select function, and you can build out a query that way. So something like that. Second best way would be a stored procedure, and in cases where an ORM or a prepared statement just doesn't make sense because the SQL query is so complicated. A stored procedure is going to be your best way, where you pass through a variable as a function. The one note I forgot to mention here, that prepared statements still can be vulnerable if your underlying SQL is doing what's called, it's just an exec, where you say exec and then the SQL string that you put in, instead of making it native SQL, you can inject code in.
Yeah, I would say anytime you are building your own SQL in the code, stop and really rethink it, because generally that's where the
If you're seeing
vulnerabilities are
string
introduced.
concatenation,
Yeah. Anytime
that's
you're
like the red.
string concat. Yep. Anytime you're building your own.
I'm not gonna lie, I saw that in the wild.
Yep.
A few weeks ago on a client engagement. So we helped
Always,
them fix
my
that.
heart always sinks. My stomach falls when I see that in the wild. I'm like, oh God, now I feel like obligated to look further, and then
Yes.
that really starts to scare me.
Yes, that when you find it in one place, you're more than likely going to find it in another area.
Well, and here's the problem, right? Is even if it's done right in one area, the problem is somebody else sees that. They're like, oh, that's how you do it. You just concatenate together, and then they build one. And they like, because if it's built without parameters, generally it's safe. I'm not gonna say always, right? But then somebody will add parameters without doing a prepared statement, and that's where it all goes south. And then somebody else sees it and copies that same pattern.
Yes, yeah, that is, you're describing to a T what we saw in an engagement recently. So then the last option that you don't want to use, there's no reason to use this beyond just lack of knowing these other examples here, is doing the escaping yourself, trying to escape the different inputs and things like that before calling the database. Brandon, am I missing anything else there with SQL injections?
No, I think it's we're gonna constantly see those around. I think you'll have to watch, especially when we're picking up legacy code. A lot of legacy code never thought of the cybersecurity angles because it was written 10, 15 years ago.
Yep.
So I think you'll see more of it if you're picking up legacy applications.
Yep. Yeah, absolutely. So moving on to the next subject here, we're going to talk a little bit about cross-site scripting. And so cross-site scripting is very much, and actually before I move on too fast, if anybody has any questions, feel free to put them in the chat. We'd be more than happy to help. And the notes will have links to all the things we've talked about here, including a link to OWASP's website, which is the Open Web Application Security Project. They do a fantastic job of listing out not just the things that we talked about here, but going into even more detail, giving you code examples in different languages and with different libraries. It's kind of I would say from a cybersecurity perspective, when you're building user-facing applications, it should be more or less your Bible from a security perspective of getting started. It might not be the only thing that you need to reference, but it's going to be the best place to start in any situation. So I would definitely recommend being familiar with it. And I'll actually put it here in the chat. The link to their website. And specifically, you can actually see some of their top 10s here, where injection is their number one web application security risk. So moving along to the next thing we want to talk about is cross-site scripting. So this is something, again, this is more of a web based attack than any other type of attack or any other type of vector. You won't really see this in desktop applications or command line applications or something like that. But if you're building a user facing web application, PHP, HTML, CSS, JavaScript, any of those languages. Even if nowadays, if you're probably, I don't know if this is applicable to WebAssembly. I haven't done anything myself with it, but I wouldn't be surprised if there's some sort of control or issues that you would need to account for. The idea of cross-site scripting is that as a malicious user, I can interact with the site in a way that adds additional code, specifically JavaScript, but it could be other vectors, to a susceptible website. In that I can get another user to execute this code and it will do something that they don't expect or that is more than likely malicious. A great example of this, actually, let me see if this is actually still valid. Sorry. Yeah, so there's, no, I might be mistaken. I don't want to misspeak about it. So we'll just talk about the types of cross-site scripting. So as a malicious user, when you're going to a site and you're trying to perform some sort of cross-site scripting attack, what you're trying to look at, there's two different ways you can approach it. And again, as a developer, two different ways that you need to think about how a user could misuse this. The first is a persisted cross-site scripting attack. So a great example of this is, let's say you run a forum where you and all of your friends talking about all your software projects, and you allow anyone to sign up and create a post. When someone goes and creates a post, they're going and typing in, and let's say you have a WYSIWYG editor. What you see is what you get. And they can go and they bold some stuff, but then you have the one friend who's they write code. Again, you guys are all developers. They decide to go in, they turn the WYSIWYG editor into the HTML editor, because sometimes they support that. So now you're storing HTML in these posts in the database. Your friends are going in, making it look really cool, doing things that the WYSIWYG editor can't do because they can do HTML and CSS themselves in there. When you go and you store that HTML, and then you have someone else go to that page where that post was made and they pull it up in a read-only view, if you aren't properly sanitizing your input when the user's creating content and running it through, there's a number of different libraries that can help support this, filtering out known tags that are bad or not allowing things like a script tag where someone could add JavaScript. If you're not doing that type of validation when a user is submitting that content and then you display it back up, it's possible that a user could go and put in a script tag into the create post field. They could go and have it, the simple test, the way that people test for this is you do a JavaScript tag with just an alert function call, which pops up just a little alert on your browser, just as you alert hello world, something along those lines. And the persistent part of it is the fact that you're creating this post, and now anybody who sees that post, who pulls it up, it's being pulled from the database and served to the users. So that's a type of persisted cross-site scripting where someone's putting in something malicious, some sort of scripting thing. And the reason I say script tags aren't the only thing, people have done this with CSS where they've used like a background image field and some additional other fields to go and link to other resources that when the browser executed it, it caused a cross-site scripting. So there's a whole bunch of number of different ways to handle this. So I would definitely recommend checking out OAuth's website for validating this for the various different ways that you might be using it in your application. The other type of cross-site scripting is called a reflected attack. And this is more when, let's say, you... Pulling up my second page of notes here. where a reflected attack is essentially a non-persistent attack. This is where nothing's really saved to the backend. So maybe it's a link that you give the user that has a query param that's fed into a field on the page. There's also the possibility of maybe setting a cookie. That's one way, like if a cookie is being read in and rendered to the page or local storage. Any sort of reflected attack is anything that's not super, it's not persistent in the back end. It's something that the user can go and put into the page. It's a little bit more of an obscure one to really execute. Typically the ones that we see the most, I've seen the most at least from ancillary knowledge, is stored cross-site scripting, where someone's not validating the HTML or you're getting HTML from an untrusted source. So the protection against this is just sanitizing input. If you see that you're taking user input and rendering it immediately, so you're letting them put in like an HTML tag, or they could put an HTML tag in it and then you're just rendering HTML raw, or just taking that string and just printing it out to the screen, you might have a cross-site scripting attack there. So you'll want to do some sort of escaping of that content. I know nowadays most JavaScript frameworks put in protections for this, or at least basic protections for it. Again, familiar with React, and so with React, you have to call unsafe render HTML on a function or on a element to get it to actually render whatever your content is as HTML and not as text. So you have to be pretty explicit about it in there. And when you do that, you need to make sure you're escaping it and providing your own security controls, because they're not. I'm sure other frameworks do that. I'm just not familiar with them enough to talk about it. So moving right along, talking a little bit about cross-site request forgery and CORS. I won't bore people too much with this one. The idea, though, is that when we talk about web applications that are where you're running client-side JavaScript code, that JavaScript executes in the client's browser, so on your computer. So if I'm a system administrator, I have my API, and I have a web server serving up my JavaScript code. The JavaScript code gets downloaded by the user. It runs in their browser on their laptop or on their desktop, and then hits our APIs. So cross-site request forgery and CORS are, cross-site request forgery is where someone is running an application. Let's say you run a banking application, and you don't have CORS in place. CORS is what's used to prevent cross-site request forgery. And so someone sets up a malicious site that looks just like yours and sends in a user a phishing link that they click on. They go to the malicious version of the site that looks the same, but it's not actually the same. That site could make requests from a different domain. It's assuming it's running on a different URL to your banking API. And if you don't have CORS in place, that request will just go through. So the idea of a cross-site request forgery is that someone is making a request from a different domain that you don't expect to one of your APIs via some sort of JavaScript code and performing an action you don't expect. So a great example of this is if they were trying to, you click a button on a website and it goes and transfers all the funds out of your bank account. You wouldn't be very happy about that, and you'd be very disappointed in your bank, and you'd want to switch. And so what CORS is a way for it's something that the browsers enforce. So Chrome, Firefox, and Safari, and Opera, and any of the others out there. Yeah, Edge, Brave, they all support CORS and enforce it. And the idea is that if you're making a JavaScript request from one domain to an API, that API needs to have a specific set of headers that say, hey, we're going to allow requests from this domain. So when you see if you ever get a CORS error while doing web development, the answer is not to go and allow all domains. That's typically what you'll see on some sites. The solution is to go and add a CORS header for whatever the domain you're making the request from. So if you're doing local development to, let's say you're running on localhost 3000 for your React application, and you're running on localhost 8080 for your backend, you would need on your backend to go and say, hey, we're going to allow requests from localhost 3000. So there's some examples here in the docs of how you'd go and set it up and what those headers look like. But keeping that in mind that you just don't want to turn it off or just allow all, as is with anything that we suggest. You'll want to go and tune it for your use case. So, Brian, do you want to talk a little bit about dependency management since I've been talking here for a little bit?
Sure, yeah. So, I mean, as software developers, obviously we're using libraries to do things, or hopefully we're using libraries, right? That's the productive way. But a lot of people kind of just grab a library and use it. What we try to encourage is people to look at the libraries, see who's supporting the libraries, how active are the libraries, how many people are using the libraries, to make sure that they're staying up to date. Because, a lot of these problems of vulnerabilities, especially if they're in an existing library you're using, if they're not being kept up to date, those vulnerabilities kind of leak into your code over time.
Well, not just that too. It's also is it even going to be working? And if you have a bug, I mean, that's typically the problem.
Yep.
That's the problem we run into first. Is this is, I'll say, really prevalent in the JavaScript space. Is it's like, oh, I don't know how to do X. Well, there's a library that does X, and it's written by one person who wrote it as a project. Well, they were trying to get a job, and they don't.
Is it 508 compliant?
It might not be that. Yeah.
Where there were some bugs with the 508 compliance and keeping those up to date.
Yep. Yeah. So a great example of why dependency management, I would say this is probably one of the more, all of these things that we've talked about are kind of the first items that I typically look for in an application. Because dependency management, a great example of not having good dependency management was the Equifax hack. In that they had a vulnerability in their code in the Apache Struts library that Apache Struts had fixed a while before the hack had happened, but they just hadn't updated their dependencies. They were running the same version, and then a malicious user found out about it and was able to take advantage of it, unfortunately.
Yeah, we kind of also call, like, when things get out of date, technical debt. And as the further out of date it gets, the larger your technical debt generally becomes, because if you're not able to, say you're not able to keep all one version, right? No big deal. 2 versions. It's a little harder. When you get 3 or 4 versions behind, then updating that library now.
Upgrades you have to do.
Yeah, well, that library depends on 10 other libraries, and that starts to cascade quickly. And next thing you know, you're like, oh my God, it's impossible, right? It goes from like, it's a few days to now weeks and months or never.
And sometimes you get to the point where it's so old that there isn't an upgrade path anymore. It's less and less common nowadays with central repositories like Maven Central or NuGet or NPM. But it's still possible that a library provider decides that, hey, after 5 years, I'm going to take the old versions offline. I don't want them to be accessible. This is especially true with paid libraries. And if you're using non-open source libraries, that there might not be an upgrade path. You might have to either go and pay for support, which then costs money, that then you have to get these old versions, and it might not work on your operating system anymore to go and do the upgrade. So getting those steps after a certain while become extremely difficult. Whereas if you just did the upgrade early on as part of your normal cycle of just development, the friction is a lot lower.
Yeah, the other thing to consider, like with a lot of dependency management, is, why am I using this dependency? What dependencies is it pulling in? I know when we do a lot of reusable and libraries that we're sharing code or sharing products with other teams, we have to look at that. I think, there was a good example the other day. We had some really simple utility library that someone shared with us, and we included in the code and add 10 gigs of extra code because they just weren't cautious about what they included. And so, as a software developer, be cognizant of what the dependencies are pulling in and how many dependencies and how big that chain becomes. Because, once you pull that big chain in, you have to keep everything that up to date. And then, as those change, you might have some silly utility that depends on 10 gigs of code. Well, now that 10 gigs is constantly changing. So, we found there was a simple library that we could use, did the same feature and had 0 dependencies, right? And so that, which library do we want? We want the one with the least amount of dependencies in those cases. So be cognizant of, when you're pulling in other code and, you give somebody some simple utility. Where's my phone here, right? I know space is getting cheap, but like all of a sudden we put like, a 10 gig file, you want to download that, right?
Yeah. I mean, that's definitely true with JavaScript and with mobile applications. Is the amount of dependencies you bake into your app is how much the user is going to download. It's going to take up space on their phones.
Those of us not on unlimited plans, I start getting the text messages. You're at 50% of your plan, 75%. You're 125% of your plan, right?
Oh, and Dustin, Wild Dustin's popped into the chat here. Careful with JavaScript versioning too. Going back to our versioning discussion.
We have a Saturday class for that, Dustin.
Versioning, minor versions, theoretically, should be backwards compatible. But
always should be backwards compatible.
But that sometimes is not the case. I'm not going to say not even just with JavaScript. JavaScript is very common for this, where in your package JSON you have what they do. I don't know what they call it because I don't like using it, but they auto increment, like allow you to automatically upgrade your dependencies with like a little caret symbol. There's a couple different other symbols you can use to manage it. But the idea is that it will auto increment the minor patch versions or minor versions for you. And sometimes that will just break your code because someone new on the team runs an npm install and it just goes and pulls in the brand new version that's not actually backwards compatible. Or typically what happens in JavaScript in most languages when you do a minor version upgrade, where it's not a hard thing to upgrade, is like they'll deprecate a function and have a replacement one that you'll just have to go fix. Something that's not a huge hurdle to climb. It's not like, oh, you have to rewrite your whole application. It's like, oh, you have to change this one line of code, or we change the import name of this thing. That's pretty common in a minor version.
Well, it's technical debt. As you slowly keep those things up to date, it's easy.
Yeah.
Right. It's no different than school, right? If you work on your project, throughout the semester, when you get to end, there's not a lot of work. If you wait to the end to start it, it's that big mountain, right? It's a big hurdle. So technical debt is a real thing. We talk about it a lot. And when we do a lot of agile processes, we typically allow, depending on the size of the application, anywhere from 5 to 20% of our allocation to reduce technical debt and keep up with things, right? As the larger the application, the more you have to allocate time towards keeping up. Maintenance.
Yes.
Such thing as maintenance, right?
Yes. It's the moment you write the code, it becomes technical debt.
Yeah, I have no idea why my car breaks down. I do no maintenance, right? Everything requires some sort of TLC over time.
Yep. Let's see. I think we covered most of the topics here with dependency management. There are tools out there that will go and automatically scan your project for dependencies that have known vulnerabilities, keyword being known. Things like GitHub does this now for you. They'll try to auto increment your versions for you if they see you're using one with a known CVE. But you never know if it's, again, this is where validating and vetting who you're pulling in code from and what your own code you're writing is if there is no known CVE, but there is a vulnerability for it that just nobody's found yet, you'll need to pay attention to that.
Yeah, there's some kind of cool syntax that allows you to use the latest version of libraries, but be cognizant of that. Like, right, I never like
that's the caret thing that I was talking about. It's like the auto incrementing versions.
Be careful because it'll auto do it, right? And so you might get unexpected results. I would make sure you're continuing to test that.
The funny thing is npm has a lock file. Yarn does this too because it runs on npm. To go and solve that problem so that you don't auto upgrade the versions
in production without knowing on a Friday night at 5 p.m. Right? Nothing ever goes wrong 9 to 5, right? It's always after hours, and it's usually right before you have something important like you're getting married or there's some huge life event. It's usually right about then when things go wrong.
Yep. All right. So moving on to the next section here, PII. This is Brian's favorite topic to talk about.
Gives me heartburn.
The number of things. This is probably of all the things that I've seen in the wild Improperly
Oh,
storing or improperly securing PII is definitely one of them.
yeah, we see this all the time. You know, we do a lot of real estate investing, and the amount of times they send me my social security number in the wild, I literally cringe every time I get an email. I look at it, just shake my head.
Yeah.
I
Yeah.
had to literally call someone the other day and give them a PII discussion and cybersecurity discussion about sending, information in an email unencrypted. So, we see this all the time.
Yeah. As a developer, it should be your goal to build applications that allow users to protect their own personal information from not just other prying eyes, but also from you making a mistake and from malicious users and incidental exposures. So I'll say we consider PII pretty broadly because it is pretty broad. There's no one piece of information. I mean, one piece of information alone can be damaging, but the combination of all these things, if someone gets some of this information from your application and a little bit from somewhere else and a little bit from somewhere else, they start to build a picture of the person, especially if they're looking to do that, to commit identity fraud or open malicious accounts, doing crypto mining. There's all sorts of things that people just advertising.
Yeah, I mean, a simple example is a credit card, right? Usually, we do a lot of credit card verification in the travel industry. Usually you just need the zip code. So that gets into their driver's license or their address, right? And so, having a credit card alone typically isn't as big of a deal, but you need some sort of verification. I don't know if you go to the gas stations, they ask for your zip code, right? A very simple concept, right? You think your address is harmless, but now you combine it with that credit card. Now they have enough information to go make purchases.
Or they combine that with your email. The most common one that baffles me is that your email account that you use to sign up for things. If in like a data breach or something, if your email is exposed and your password's exposed, the problem with that is now more than likely, if you're not using a password manager, which you should, your password is going to be the same or similar across other sites. And typically, I'll say most people don't use a different email address for every service. You can actually do this with things like Gmail. You can add a little plus sign at the end, or if you have your own domain, you can just make infinite email addresses. That's what I do. So that way my email and my password are never the same on two different sites. So if my information is breached, they can't reuse it somewhere else. So email and password is definitely one of those.
Two-factor, you're not going to get on your horse and get.
Yeah, two-factor is definitely the number one way to protect your accounts and protect your own PII is having two-factor. But obviously, if as a developer, if you don't implement that or implement controls and someone hacks your database, that's kind of moot. The other thing to consider with this is the encryption of this information, and really just this is something nowadays that I would just suggest carte blanche. It's very easy to do, is setting up encryption at rest. We've already talked about encryption in transit, so HTTPS and SSL or SSL TLS, and using that and SSH and why all those things are important. Encryption at rest is now a lot easier than it used to be. It used to be that you have to have dedicated devices and they cost thousands and thousands of dollars to encrypt your hard drive. Nowadays, it's typically enabled by default, especially on professional grade computers. So if you're doing like a Surface Book Pro and you buy the Pro or the business version of it, it's going to have BitLocker enabled by default. But if you're hosting an application and you run an AWS, there's literally just a button you click that says encrypt at rest, or Azure, or I'm not sure about some of the other providers out there like DigitalOcean or Linode or anything like that, but I'm sure they have options for it. So encrypting your data at rest is important. Even going as far as to encrypting individual fields in your database. Most databases have the ability to do field level encryption, or at least document level or row level encryption. So that way you can encrypt the row of data. Again, just providing other layers of security on top of just the raw data there. One thing that I don't think we've talked about here, but kind of falls in this and falls in a couple other areas. We talked about it briefly, I think, in hashing encrypting, is not storing users' passwords in the clear, hashing them before putting them in the database. So this is performing a one-way function. We would suggest bcrypt for this. As of right now, at least, that might change in the future. But bcrypt is the best way to go in and hash a password. And then if you're storing things like social security number or bank information, storing or encrypting that in the database as well is typically one of those things you'd want to do to make sure that you aren't exposing that. If you do a select star from the database, it's not as easily. And storing the encryption key not on the database. So there's some separations there. So if you're dealing with PII, consider how someone could misuse it, or really any data you're collecting from users. Consider how it could be misused, or how the combination of this with other things could be misused.
Yeah, I think a lot of people don't understand that, it's more than just the list there. It's really anything that can be used to identify that user. So if you have specific things at your organization, just be cognizant of like unique account numbers that identify users in your organization, that if people obtain them, they could call in and potentially perform activities within your organization. So
your phone number is a great example of this. Is if you know someone's phone number, you call into their telecom provider, and you can go and do a SIM swap and take over someone's phone. It's with a little bit of social engineering. Unfortunately, it's not hard. So that's just the design of that industry. That's a problem. So that's broader. Sometimes you can't solve it, but yeah, especially if you have something internally that you could use. That's important to keep secure.
Yep.
So we talked about encryption here, encryption at rest and encryption in transit. Moving right along, secure logging. So this is something that sort of goes hand in hand with PII. In addition to some of the other topics we've talked about in the past, the idea of secure logging is just don't put things into your log messages that you wouldn't want to show or send out to anyone on your team, really, from a sensitivity perspective.
Like PII?
Like PII, yes. If you're logging a message of, wow, hey, we can perform a credit check on this person with the social security number 123456789, you shouldn't be doing that. At least the caveat I'll say is PII, the only time that I would ever include it is probably at whatever your most verbose level of debugging is. And even then I have concerns with it, and most of the time would not. So in our model of logging that we follow, trace being the most verbose, that would be the only place that I might put it, because the likelihood of that ever being on in production should be never. You should have other controls in place, but that's not always the case, which is why I typically are on the side of just not logging PII ever.
Or you could simply set up the logging with an additional key configuration point. I know Dustin's with us in spirit, so I will have my Dustin spirit animal with me here.
I actually have a better solution that we don't have in our notes here, is if you really need to be using PII, or you're trying to understand what's going on, the reason that you're adding it to a log in the first place is probably because you're debugging. This would be a very good example of where you should use a debugger. And I would actually recommend for some sort of IDE that does your debugger, or learning how to use, if you're using command line, whatever the command line debugger is, but a debugger that you can step through the code instead of just adding log statements for PII. It's one of the better cases for using that.
Yeah, I mean, another instance, we do a lot of data protection and different things with data where users aren't allowed to see certain fields or certain instances of data. But then I'll go look at the logs, and the developers are just carte blanche printing that out. So be very cognizant. Anytime you're protecting, even if it's not PII data, anytime you're protecting data, sensitive data, we could start getting into healthcare data, but I mean, any sensitive data, really, be cognizant when you're logging that, because, a lot of times, logs with Kibana these days and other tools, they're throwing the logs in and allowing people to search on them. We protect this data in one place, but then we throw it in Kibana, and I was able to clearly see all of this data in another place, and it made absolutely no sense. And the team about fainted when I showed them this. So just be cognizant of what you are logging.
Well, and that's why paying attention to logging is important. I think Facebook got in hot water for this not recently, but all these events blur together nowadays. that they had passwords being logged out and sent to their logging servers. And so,
well, the other thing with logging too, right? I don't know if I always share my be professional. You never know who's reading it, right?
yes,
I had a really good developer I had to fire once because they vented in a log message and it printed out, got to production, and lo and behold, somebody from upper management logged into the log server and saw it and started asking about it. And we, obviously with configuration management, figured out who put it in there, and it was using choice words and discussing other people on the project, right? And so, ended up in his termination. So, be cautious what you write in log messages, even thinking that like, oh, he thought he removed it. Well,
I think we can go as far as to also
geez.
extending that to just be careful be professional in the code that you're writing. Any line of code that you check into version control, that could be a comment. There is a project we have that we inherited a bunch of code.
Oh yes.
Thankfully, some of their comments aren't necessarily professional, but they're not rude. They're more of just comedic.
Yeah, they were talking.
They have some jokes in there.
I thought this is the one where they're telling that this code that they're writing is bad. Like when you're checking in things saying that I'm doing a bad job, like that's a really...
you shouldn't leave a comment that says, you should just do it the right way.
Yeah.
This is probably not the best way, but we have to get this done, so I'm just putting this in here. It was the comment, more or less.
I remember seeing some of those going, oh my gosh.
Yeah. It happens. We see it all the time.
Let me toss that softball up for management. Hold on.
Yeah. So last part of this module here is static code analysis. This is one of probably the best things that you can do to just a remedial level of security is a static code analysis tool.
Well, actually, the danger there is if you don't do it, somebody actually may.
Is running your code through the code itself statically, in that it's not running, through a tool that will look at the logic in the application and interpret the language for known common vulnerabilities. A great example of this is in Java, we use spot bugs and PMD to go and do this. They run through and they tell us like, hey, you have an unchecked null case here. In that this variable, you don't ever check this for null and it could possibly be null. The other option is something like SonarQube. That's an actual server that you run that runs through many different languages: JavaScript, Java, .NET, C#, PHP, a little bit of everything. And will tell you, again, similar concept, things that are known vulnerabilities and could cause known issues within your language for you to go and resolve. These only run your code statically, don't run your application. They just look at the logic of the code. And so only go as far as you can go statically. They're not going to run through your application. To go and truly do that, you have to have a person go through and dynamically analyze your code. But setting these up, we typically run these as part of our build process. Find bugs and PMD is an example we put in our Maven or Gradle project. So they just run every time a developer runs the code. And then SonarQube will run on our build automation during our DevOps process.
I love all of those tools, right? Because it's just free part of the DevOps process. Set it up once, forget it, it's there.
Yep.
Right? I always talk about feedback is the way that we grow. And those are just more and more feedback loops. The more feedback loops we get, the better off we are. And what I love too is setting those up because new people on the team come in, especially, rising professionals, and they'll get that feedback right away. And that allows us to grow. So don't get upset when you see those things. Research it, learn from it. Like, hey, why shouldn't I do this? Right? Okay, cool. Sometimes, there's, software development can get a little religious of what is right and wrong. Sometimes best practices are out there and there's times to avoid them, but use that feedback, grow, set that up. I think it's awesome to have those things out there.
Oh yes, Dustin made a good point here too. Static code analysis tools are great for inherited projects. So if you take over a code base, running the code base through a static analyzer might not work even. I mean, that's kind of that will tell you where the project's at is if you can even run it through it. But
at least you know where you're starting.
Exactly. That's the whole point there is you run them through and you kind of get an idea of what you're going to be expecting out of the code. moving forward? What sort of problems you should expect to encounter?
Well, all the unit tests should tell you.
I don't think we've ever inherited a project with unit tests, ever.
Well, usually they're turned off by the time we inherit them.
Typically, what we find is we get them with that they have the project name and maybe they have a test one. They have a test file. Like, hey, could I get the tests to run? And then there's none others in there.
Yeah, or it's like we should add more tests.
Yeah. Yeah. I don't think I've ever inherited a project with tests. That's for sure. So, moving on to our last module here for the day. This was a relatively short one. Just talking about as hosting services and virtualization, sort of things to keep in mind as a system admin or a developer. Nowadays, there's so many different options for this, and it's pretty easy to get overwhelmed with the ways you could go and even host a site. Sometimes you don't even need to run a server to host a site anymore. There are plenty of options out there that you could do serverless, quote unquote, and they solve a whole number of problems. So typically what we'll start with is just local development. When you're working locally, having an understanding of how you're going to deploy your application is definitely the first step. I'm going to ignore most of the serverless concepts right now, mainly because those you typically just work within the serverless framework that is supported by that system. So I'm thinking of things like Vercel's one of them, Netlify. I can't think of any others right now. But those are all ones where you just upload it directly to their server and they just take care of everything for you. And that works really well for a certain type of application. A lot of the applications we build require some sort of back end and front end that are all custom. So we have to go and do a little bit more of the lifting ourselves. So typically what we'll do nowadays from a local development perspective is use Docker. People have probably heard of it. If you haven't, all Docker is a way to isolate a specific application to its own sort of security domain that allows you to run it repeatably. So the problem it really solves is the works on my machine. You can set up a Docker container with configuration that will work on any other machine if they have Docker installed. So it makes it very repeatable. And the difference this sort of replaced is the concept of just virtual machines, where you have a whole operating system that needs to be configured that you could, yes, copy and clone, but these are multiple gigabytes images. So a virtual machine easily could start at 4 to 8 gigs and grow once configured to 30 or 40 gigs possibly. So copying that around and making it portable is not easy. Docker, on the other hand, says, hey, we don't need to emulate the whole operating system. We just need to emulate this one application. So they typically range in a few megabytes to maybe a gig on the really high end. And even those are not the super portable ones. So when we're doing local development, we'll end up setting up Docker containers for things like our database, for other services that we need to use, emulating email server, things that used to be really difficult or you'd have to have dedicated servers for, you can now just run as a Docker image locally. It just speeds up the development process infinitely.
Yeah, we don't have like the 30 steps to follow to set up the email server in your example.
Yeah.
Or the web server, you have to do these flags and set this. And somebody always misses one step. And then, I remember we'd be pulled in and have to figure out what step was missed, right? Because we knew the instructions worked. Now, which step was missed?
Now it's run the Docker Compose up and all of the necessary services just start running, and then they can run the application. Easy peasy. It makes the friction a lot less friction in getting anybody set up on the team. So the other thing with Docker that we really prefer from a development lifecycle perspective is then you can go and deploy it really anywhere on really any sort of application stack. We use AWS pretty heavily in Kubernetes, but there are a lot of other options out there that work exactly the same or have a subtle difference in management tooling that might be beneficial. We use Kubernetes because we need some flexibility, but there are things like I think Fargate, AWS Fargate uses this or uses containers, Elastic Container Service. Beanstalk, I think, uses Docker containers. Beanstalk might be a little bit different actually. Azure has some concept of this. DigitalOcean has some concept. Everybody nowadays has some sort of concept of running a Docker container or a container concept where you can run it locally or on their platform. And the nice thing is that it should just work exactly the same as what you have locally. From a standpoint of hosting, let's say you're not developing an application. You just need to host a service though. You need to set up your GitHub or your GOG server or Git server for hosting your code, or a PHP application that you just don't want to put in Docker. So then you're just talking about either a virtual machine of some sort or a virtual server. And there's an infinite number of places you can go and host these with ranging accessibility to customizing and expanding it out. So depending on what you need, there's all sorts of different providers out there. Again, personally, like I said, we use a lot of AWS. So my default, if I need to host a service, is I'll stand up an EC2 container. But that's typically a little bit overkill, especially for personal projects. You might be able to get away with something like a DigitalOcean or a Linode or GoDaddy or Bluehost. All of those have, again, varying ranges of technical expertise needed. Things like GoDaddy or Bluehost typically are on the less technical side and will do a lot more for you, but still allow you to log in. I'll say I'm not a fan of them, but there's still a use case up for them. For personal projects, I would definitely recommend something like that's kind of an intermediate from Bluehost or 1&1 or GoDaddy and something like AWS, something like DigitalOcean or Linode, or something where you can just say, hey, give me a Linux server with this operating system, and it stands it up for you, and that's all you need. You don't need a virtual network and security groups and things like that.
Well, one thing to be cognizant of too is vendor lock. Like if you're using any of the features for any one of those, pick your favorite environment, just be cognizant of vendor lock, because I know a lot of customers have made decisions to use vendor tools, and then when they get frustrated, they want to move off that vendor. It's a complete rewrite or a partial rewrite, and they're not aware of that concept that, oh, I can't just lift and shift this from my Azure to my AWS or my your other.
It's not that that's a bad thing. This is something that Brian and I have talked about.
Yeah, just be cognizant of it.
Be aware of it and be sensitive to it.
Make doesn't mean that vendor lock decision.
Yeah, vendor lock is not bad. It just needs to be intentional and well placed.
And if you're working with a customer, make sure they understand that the decision is vendor locked in, because that may not be their intention. If you make that decision for them, they might be upset later. So this gets into manage the expectations. Nobody should ever be surprised if you're doing it right. So just let people know that, hey, if we go down this road, that's going to cause vendor lock. We can only host it in these X number of environments or this one environment. Just let them know. Or we'll have this licensing cost every year. Just make sure they're cognizant of what those decisions mean, the ramifications today and tomorrow.
Yep, 100% agree. So that's everything we have for today. Brian, is there anything that you think we should talk about?
I think Pat would want us to, he's not here this morning, but his spirit can be here. He wants...
if you can check us out, give us a subscribe here, like and subscribe here on YouTube. Over this next year, we'll be posting more and more content in addition to these live streams, but other videos to help you as you get into the IT industry and as you grow your career in whatever avenue that you're looking to pursue. Hopefully our content will help you. Additionally, if you want to check us out on any social media, LinkedIn, Twitter, Instagram, we're on all of those. And then if you want to check out, if you're looking for more content or things to do, if you want to check out our Rising Professional Challenge series, like Brian alluded to at the beginning, this is a fantastic way to augment what you're learning here in a way that will, there are different books and different challenges that we have to help you grow your skills outside of just the technical.
Yeah, I mean, as always, you need all of these other skills to be successful in your career, in your technical career. And, one other thing, feel free to share all of these links with anybody.
Yep.
Feel free to invite others here. Our goal is to, extend learning into the everyday environment, which means, broader and broader, to help everybody grow, because as we grow the people around us, it helps us rise. So never be afraid to help people around you. People are always worried they'll be smarter. Honestly, I'm successful because I do surround myself with smarter people. So try to do that too. And if you can make them smarter, help them grow, it'll also challenge you to grow too. So I have always found it never hurts me in my life to help those around me get better. It forces me to step up, or they're better off to help me too. So,
All right. Thank you everyone for watching. And I think next week is the next class, Brian?
hold on, I'll look.
That wasn't prepared.
May 8th.
May 8th.
Is that next week?
2
weeks.
2 weeks. 2 weeks. So we'll be talking about career versus job, resumes, technical interview guidelines, and retrospective and feedback. So
Wow, this session went fast.
it did. Yeah. So, all right, everyone. See you.